Hi guys, my name is Beyza Nursel and today I will be explaining my assignment 10. Okay, let's start with these methods. I will tell what they are used for. So, add value. Its purpose is adding a new key-value pair to the dictionary. If the key already exists, it updates the value associated with that key. So, K key, the key with which the specified value is to be associated, and V value to be associated with the specified key. And it returns the previous value associated with the key, or null if there is no mapping for the key. And now we're with the remove method. Its purpose is removing the key value pair associated with the specified key from the dictionary. And KK, the key whose mapping is to be removed from the dictionary, and it returns the value that was associated with the key, or null if the key was not found, obviously. And now we'll go with the get value. Its purpose is retrieving the value associated with the specified key in the dictionary. And K is the key whose associated with the value is to be returned. And it returns the value associated with the specified key, or null, of course, if the key is not found. And for Boolean contains, its purpose is checking if the dictionary contains a mapping for the specified key. And key K whose presence in the dictionary is to be tested if so what it returns is true. It returns true if the dictionary contains a mapping for the specified key, but otherwise it returns false, obviously. And Boolean is empty goes for its purpose goes for checking if the dictionary is empty and contains no key value mapping. And it returns true if the dictionary contains no key value mapping, and false. It returns false otherwise. And it gets size. Its purpose returns the number of key value mappings in the dictionary. And the number of key value mappings in the dictionary is what it returns. Okay, the number of key value mappings. It actually gives us a number, basically. That's what I'm trying to say. And void clear. Its purpose removing all key value mappings from the dictionary. Post condition is for after calling this method, the dictionary will be empty. Okay, now we're through with this place. We're done with this place. I will talk about this one. Okay, let's start with here. What I try to do here, basically, I use the hash table logic an array of linked lists where each list stores entries that hash to the same index. And I use an add method here. Add method. So my purpose was adding a new entry or updates the value if the key already exists. I mean, if the load factor exceeds the maximum, the hash table is resized. So yes, and for the remove, I try to remove the entry with the specified key and returns its value. So get value retrieves the value associated with the specified key, and it checks if a key exists for boolean. If it exists, and contains true if the key exists in the dictionary. For the boolean is empty. Okay, for the boolean is empty, I try to check if there are entries, and it returns true if the dictionary contains no entries. So with the get size, I try to get the size of the dictionary. Public int get size, return number of entries. Okay, so it returns the number of entries in the dictionary. And now we're here for clearing the dictionary. So it removes all entries from the dictionary. Okay. So get hash index. As you can see, I divided this. And get hash index is used for computing the hash index for a given key. I hope I could make it clear. And now, what I try to do for calculating load factor, it calculates the current load factor of the hash table. It's simple. And now we're here for resizing the hash table. Resize method doubles the size. It's important. It doubles the size of the hash table when the load factor exceeds the maximum and rehashes all entries, basically. And it represents entry class represents a key value pair. I can tell. So I'm just looking if there's anything I didn't talk about. But no, and now I will talk about hash dictionary demo. Okay, so I already wrote my codes from the beginning, but there is one thing missing, and now we will write together to show you how I made it, how I create this. Just showing a little piece of code. Dictionary clear. Size after clean. and clearing. And now I need to add dictionary get size. And for this one, is the dictionary empty? I need to ask dictionary empty. Um, yes, I think we're done. Okay, so now let me talk about my code quickly. Main demonstrates the functionality of the hash dictionary class and add entries, adds 3 entries to the dictionary. As you can see, 1, 2, 3, 3. It adds 3 values and prints the size. And for get values, it retrieves and prints the values for the keys 1, 2, and 3. Check contains is for checking if keys 1 and 4 exist in the dictionary. And removing an entry removes the entry with the key 2, then prints the size and tries to retrieve the value for 2, and clear dictionary clears the dictionary and prints the size and whether the dictionary is empty. So let's run our code and see what we get. Yes, our response is exactly what we're looking for. Size after additions 3, 1 to 3 is added. Value for 1, 1, or 2, 2, or 3, 3. Contains 1, true. Contains 4, false. Size after removal. Removing after removing 2. And size is 2, became 2. Value for 2 after removal is null because it doesn't exist anymore. Size after clearing, and it cleared all. And now we have 0 entries. Is dictionary empty? Yes, it's empty. It's true. And now I will tell, so we will talk about these methods, time complexities. So for add method, average case is O1 and worst case is ON. For worst case, if all keys hash to the same index, it's worst case, ON. And for remove method, average case is O1. Removing an element is a typically constant time, but worst case is ON. And for get value, it's same as remove an end. For contains key k value method, average case is O1 and worst case is ON if all keys hash to the same index. I mean, if you can handle with one entry at the same time, it's an average case, it's O1. But if all of your keys is trying to do something, then it's worst case. We don't want all of them to go somewhere or to, we want them to act separately. And is empty is O1, checking if the dictionary is empty. It's constant time. And it's same for get size, same for clear, but there's a difference for clear. Its time complexity is ON. Clear in the dictionary involves iterating over the hash table. And for resize, same logic for clear. For resize is on. Resizing the hash table involves rehashing all entries. We're going for all over the table for clear and resize, so that's why their time complexity is on. So that's all for today. See you.